Hi students, I am Praveen Sebastian Paul. In this lecture, we are discussing the reduction rules for SOP using KMap. There are a couple of rules that we use to reduce SOP using KMap. First, we will cover the rules step by step and then we will solve the problems in the upcoming set of lectures. First of all, we are discussing the pair reduction rule. So let us consider the following four variable K-map, that is the variables are W, X, Y and Z. The W and X are represented as rows and Y and Z are represented as columns. Now as we see in this figure, since we are dealing with the SOP, the minterms are M3, M4, M7 and M12. Now we will mark the cell in pair, that is set of 2 having values 1. So the first rule is a pair rule. In order to make a pair, there is a condition that the minterms should be in adjacent set. That is, the first pair available is W dash X Y dash Z dash plus W X Y dash Z dash, and the second pair is W dash X dash Y Z plus W dash X, Y, Z. The pairs are in SOP form. Now, we will remove the variable that changed the first and second pair. Looking at the first pair, the W dash changed to W, so we have to remove it. And looking at the second pair, the X dash is changing to X, so we should remove it. So the updated pair after reduction or after removing the changed values are, first pair is W dash X Y dash Z dash plus W X Y dash Z dash is equal to X Y dash Z dash, and the second pair is W dash X dash Y Z plus W dash X Y Z is equal to W dash Y Z. Therefore, thus the ESOP is equal to X Y dash Z dash plus W dash Y Z. So in the pair reduction rule, the points should be remembered is the pairing should be done only for the adjacent set of minterms, and the pairs are taken with 2 raised to n pairs only. And in the reduction, we should remove the variable which are changing. So when we are considering the second rule, that is a chord reduction rule, let us consider the following 4 variable K-map. Mark the cells as chords. That means the cell should be marked with a set of 4, which is having the value 1. The first chord is W dash X dash Y dash Z dash plus W dash X Y dash Z dash plus W X Y dash Z dash plus W X dash Y dash Z dash, and the second chord is W dash X dash Y Z plus W dash X Y Z plus W dash X dash Y Z dash plus W dash X Y Z dash. So now we should remove the variables that changed the first and second chord. Looking at the first chord, W dash and X dash changed to W and X, so we should remove them. And looking at the second chord, X dash and Z changed to X and Z dash, so we should remove them. Therefore, the updated chord in the first chord, that is W dash X dash Y dash Z dash plus W dash X Y dash Z dash plus W X Y dash Z dash plus W X dash Y dash Z dash is changed to Y dash Z dash. This is because the W dash and X dash is changing to W and X, so we should remove these terms. In the second chord, the repeating or the changing values are X dash and Z. Here the X dash and Z are changing to X and Z dash. Therefore, we should remove those terms and write only the unchanged values. Those unchanged values are w dash and y. Thus, the ESOP will be y dash z dash plus w dash y. Next, we should consider the octet reduction. Here also, the point should be remembered is we should select the octet and we should remove all the changing values, and the final SOP will be the value or the variable which is not changing. Here in this set of octet, we can see that the value w dash is not changing and rest of all the values are changing. So the final SOP in this case will be w dash. The next rule is a map rolling reduction rule. In this, we consider the K-map top edge is connected with the bottom edge and the left edge is connected with the right edge. Then we mark the pairs as chord and octet. Let us check few examples. In the map roll reduction, marking the pairs are represented as in this K-map figure. Here we can see two set of pairs, and these pairs are rolled in the top and bottom as well as in the left and right. The first pair is w dash x dash y dash z plus w x dash y dash z, and the second pair is w x y dash z dash plus w x y z dash. In the first pair, the w dash is changing to w, and the second pair y dash is changing to y. Therefore, we should remove all these changing terms and rewrite the ESOP with unchanged values, and the final SOP will be x dash y dash z plus w x z dash. In the similar way, we can represent this rolling reduction for chord as well as octets. In this chord and octet, the map rolling will be considered in the top to bottom, in the rows of top and bottom rows, as well as in the left and right columns are also be rolled in this chord and octet consideration. The next important topic or the important rule should be discussed is the overlapping groups. When a value in a cell of a K-map is encircled in more than one group, even in the pair, chord or octet, then we call such groups as overlapping groups. Let us consider this K-map. The first pair, that is M4 plus M5, the second pair is M15 plus M14, and the chord is M5, M7, M13 and M15. If you look at M5 and M15, they are overlapping. The overlapping helps in getting simpler expression after reduction. The updated pairs and chords after the reductions will be, the first pair will be w dash x y dash, second pair is w x y, and the chord will be reduced to x z. And the next rule considered is the redundant group. After marking out the overlapping group, it is important to also check for redundant groups. If all the values of a group G, that is a pair, odd or octet, is covered with other groups, then the group G is redundant and ignored. In this example, the first pair is M5 plus M7 and the second pair is M12, M13. And we can also consider a pair M5 plus M13. If we look at M5 and M13, that is the third pair, it is a redundant group as M5 and M13 is covered in the first and second pair. So we will remove the redundant group, that is the third pair can be removed. The updated pair after the reduction will be, the first pair is w dash xz and second pair will be w x y dash. So these set of rules for K-map reduction for SOP can be summarized as follows. First point should be considered is prepare the truth table for the function. Secondly, Draw an empty K-map with 2, 3 or 4 variable. Thirdly, fill the cell with values 1 for which the output is 1. Fourth point is fill the rest of the cell with value 0. Next point is mark the pair octet code by encircling the values 1. Also check the map rolling and overlapping group, and we should remove the redundant groups. And finally, write the final reduced expansion and OR them with the answer. Here we should consider also a point that all the changing variable should be removed in the K-map SOP representation. So my dear students, hope you had understood this topic. So dear students, we will discuss in detail about how this K-map can be used to solve a function for SOP. So my dear students, kindly go through this assignment question. The question is, write about the reduction rules for SOP using the K-map. So dear students, in the upcoming lecture, we will discuss different examples for solving the SOP and POS using K-map. So dear students, see you soon. Until then, goodbye, thank you, and all the best.